Hello, Stand and Calling, Sunday afternoon. This is my first festival, so please go easy on me. Let's just say this is a hot topic for a hot day. I'll get that pun out of the way. No more puns about Wildfire, I promise. I'm just going to unwind myself. Okay, good. Make sure I don't trip myself up. And I never thought I'd be competing with Bjorn again. I'm glad that I'm not clashing with them today, so I can go off and see that later. Now, obviously, wildfire is a really important topic, I think. It's why I've spent the last 15 years of my life dedicated to studying them. And Tuesday, just last week, I think really emphasized how important it is for us here in the UK as well. And I will touch on that a little bit later. But this title, Wildfires and Climate Change, is a little bit obscure because there are two ways you could read it. How are wildfires responding to climate change? But also how are wildfires driving climate change? There are two really important questions here, and I'm going to try and address both of those in the next 20-25 minutes or so. What I'm going to start with is the easier question, which is how wildfires are driving climate change, and that is the question that I've dedicated the last 10 years of my research to. So what I would like you to do to start with, we're going to actually, I'm going to try and explain what a wildfire is, and I want you to use your imagination here. I want you to imagine that you're in a forest. It could be one that's close to your home. It could be in Canada, lodgepole pine. It could be in the tropics. It could be a rainforest. And I want you to close your eyes and imagine that there's a fire approaching. Now, I don't want you to imagine yourself getting fried. Absolutely not. That would be pretty nasty. So imagine that you're in a fireproof box watching the flames approach. And what you would see is as the flames get closer to your tree, you'd start to see all of the moisture from the ground, the leaf litter, the needles that might be on the surface of the ground. That would start to kind of steam out of the fuel or the vegetation. And as the flames get even closer, you start to see gases spraying off the barks of the tree, off the leaves of the tree, off the needles. And what's happening here is something really special. The heat has got so hot now that the molecules that make up the substance of the tree, the sugars, the starches, they're beginning to break down. They're cracking. That is the chemical term for this. And they're releasing volatile, flammable gases into the atmosphere and leaving flammable solids on the surface of the tree. And as that flame gets closer, as the air gets hotter, those flammable gases ignite, okay? They ignite and you end up with a massive inferno on your tree. And if you were closing your eyes like instructed, and only a few of you still are, you can open them now, and maybe your tree looks probably nothing like this. But you've got a tree on fire. And what's going on here? Now, I'm going to break the first rule of public speaking when it comes to science communication and show you a chemical equation, so please bear with me. But this is a really important equation. I'll break it down. It's fairly simple, but this is the equation for combustion. What you've got on the left is the stuff of a tree, basically combining with oxygen in the air. And what that is leading to is a huge amount of carbon dioxide, and we know that is a greenhouse gas, some water, and importantly, energy. And that energy is the light and the heat of the flames that you can see and that you can feel when you see a fire, whether it's a big tree on fire or whether it's a log burning on your fireplace, okay? That's the energy being given off from this reaction, from this really important chemical reaction. Now, what we can see here is, we've got the release of carbon dioxide from fires, which leads many to think, oh, wildfires must be really bad for climate change because they're releasing CO2, it's a greenhouse gas, it's going to drive climate change. But most fires on our planet, when you burn a tree, when you burn a shrub, when you burn some grassland in the savannas of Africa or Australia, it's going to grow back. And what is the chemical equation for that growth, that growing back? Does anyone want to shout out what this is? Can anyone tell me? Anyone? I've got some correct answers, but this is photosynthesis. And many of us learn about this as far back as primary school. But what I find incredible about photosynthesis is it's the opposite of combustion. You've got carbon dioxide now being combined with water and using energy, and of course that energy is from the sun, and it's making the stuff of a tree, the sugars and starches, and it's releasing oxygen in the process. And so it's the complete opposite. And what we see here is a natural cycle where things burn and then they regrow. It's a carbon neutral cycle where you have a fire, it releases CO2, but then we have regrowth, which sucks the CO2 back out again. And so most fires on our planet are really important ecologically. They help regrow. Think about the Lion King and the wildfire and the Lion King, and everything grows back and everything's wonderful and there's a happy ending. And that really is true for most of the planet. We've got this beautiful carbon neutral cycle. And next time you see a log burning on a fire and you see the flame and you feel the heat, just think that is the light of the sun that you're feeling there that went in to make that log in the first place. I think it's a really beautiful way of seeing this natural cycle. Even when you burn a lump of coal on a fire, which hopefully no one is doing these days, that heat and light that you see is the light of the sun that went in to make that tree 300 million years ago that became the coal. So we've got this beautiful natural cycle. Now the problem is, in some parts of our planet, we are burning forests and we're not allowing them to regrow. And that's important because that carbon dioxide that is released to the atmosphere stays there. It's not going to be resequestered from the photosynthesis. I'm picking on Indonesia here because this is a place where I do a lot of my research, but it could be Brazil, it could be parts of the Democratic Republic of the Congo, where we're seeing the loss of tropical forests and the replacement with agriculture. And so we're moving away from this natural cycle now to fires being a source of carbon dioxide to the atmosphere, and that CO2 is going to stay there. Now, we live on a fire planet. I hope you can see this video, but fires happen everywhere. This is Australasia. In the north, you've got grassland fires and savanna fires. These are pretty much carbon neutral. Whatever burns usually regrows again. You've got forest fires in the southeast. And until recently, you'd expect the fires to regrow. But with climate change now, we're concerned that we're going to see a permanent shift away from forests. In Asia, you've got a lot of agricultural fires. Many of these are carbon neutral because you burn off the stubble from one growing season, but then you have stuff regrowing the next growing season. But then we should shift to Africa. Africa is incredible. You have the growth during a wet season of grasslands and savannas, and then in the dry season, it all burns away. It's an annual cycle. If we're looking out in the south, you've got fires burning. So we have this shift. It's like a heartbeat with growth and then fire, growth and then fire. Really incredible continent. And again, generally carbon neutral, so we shouldn't be too worried about these fires. But we shift now across the Atlantic Ocean to South America. And what we're seeing here is some very unnatural fires. These are tropical ecosystems. It's wet, it's boggy, very unlikely to see a fire in the history of these forests. But humans are encroaching, opening up the canopy, chopping down trees, and that makes this system far more susceptible to fires. And those emissions, the emissions from those fires, are really important and can drive climate change. So we've got these flaming fires from deforestation. They're really important. But something else that's close to my heart is peat. I'm really interested in peat soil. And many of these tropical fires, not only do they burn the fires on the surface, but the fires are so intense that they set fire to the soil. The soil, the underground carbon that's been building up for thousands and thousands of years. In many places, this soil is meters thick or tens of meters thick. And that burns just like a cigarette. It smolders away and can burn for weeks or months, and in some cases can burn for years. And all of that carbon that's been locked up for thousands of years is released to the atmosphere, and it will take a very long time for that carbon to resequester, probably tens of thousands of years. So any fire in peat is like burning fossil fuels. It's like burning coal or oil or gas. And so we have to be worried about these smoldering fires as well when it comes to the human impact on climate change through wildfires. So we've got this natural cycle, but so far I've tried to tell the message that we have shifted away from that natural cycle because of deforestation and because of smoldering fires on peat. Now, this is the effect that these fires have on climate change. Everything on the left leads to warming, but there are also some things that lead to cooling as well. And I'm going to briefly talk through some of these. So generally, we have a lot of gases emitted from fires, not just carbon dioxide, methane as well. These are greenhouse gases, so they lead to warming, which is why we've got this on the left-hand side. Some of these gases lead to ozone. Now, ozone is very good for our planet when it's in the stratosphere, high up. But when it's in the troposphere, it's bad. It's bad for us as well because it's poisonous, but it's also a greenhouse gas, so it can lead to global warming. Aerosols. Now, I'm not talking about spray cans here. I'm talking about small bits of particles floating around in the atmosphere, and you might call it smoke. So the smoke from a fire is the small particles that are given off by the fire. Now, this is complicated, and many researchers don't really know what the dominant effect is here. But some of these particles warm our atmosphere because they're black, like soot, and they absorb sunlight and they absorb heat from the Earth. But some of them shade our planet by reflecting sunlight and actually help lead to cooling as well. So we've got this like two effects here of warming and cooling. And finally, we've got changes in the color of the land surface. This is really important for fires up in Siberia because when the soot, the black particles land on the Arctic, on the snow and on the ice, that can lead to melting of the snow and ice because it darkens the surface and makes it absorb more sunlight. But we also have the effect where you replace a tropical forest. If you ever look at a tropical forest out of a window of an airplane, it's almost black. It's really dark. You replace it with an agricultural field and it becomes lighter, and so it reflects more sunlight, and that can help cool the planet as well. Now, I've spent most of my career trying to quantify all of these things, trying to understand how big these different effects are. Mainly the gas emissions and the aerosols and the smoke in the plumes from these fires. This is just an example from one of my research sites. You might recognize this type of ecosystem. This is heather. This is a heather moorland up in Northumberland, not far from Long Framlington. Really crazy fire behavior, and we've been seeing some of that last week. High winds, dry fuel, massive flames. And what I was doing here is looking at the content of the smoke. This one here, this is northern Australia. This is a savanna ecosystem. They're having big problems here because the fires are getting more intense than they used to be, and they're killing the trees. So normally the fires are little piddly fires. They kind of crawl along the bottom of the trees, and the bark gets toasted a little bit, but the tree survives. But today the fires are becoming more intense for a number of reasons, which we might come on to, where the trees are dying. And finally, we do get to set some fires on purpose. So obviously, fire science is something for pyromaniacs. And what you can see here is an experimental fire. And this is actually on peat in the tropics in Indonesia, working with the University of Indonesia. And you can see here we're setting a surface fire, and you can see the flames flaming away. But half an hour, 40 minutes later, and you see that it's starting to smolder. And this peat smoldered for 2 weeks without us having to do anything. It just burnt and burnt and burnt. It's only 10 meters by 10 meters, but it's slowly burnt into the soil. And we measured the smoke, and we measured how fast that was happening. And we had some drones to record some really nice footage for talks like this as well. So this is Indonesia. And just give you a scope of the kind of measurements that we're making in different ecosystems. So we've got all of these impacts on climate change. How big are the effects? Well, what this shows us here, the size of the arrow is basically how big is the effects. And remember, on the left, the red arrows are the warming effects, and on the right, you've got the cooling effects. And what you can probably see here, unfortunately, is that the warming effects are the dominant ones when it comes to these deforestation fires and smoldering fires and their impact on climate change. So that's problematic if you think about it, because, well, what does this lead to? It leads to a warmer climate. That generally means, although it is a little bit complicated, and we're going to come onto this in a minute, generally means we're going to have more fires, because a warmer climate is going to lead to the likelihood of more ignitions, the ignitability of more fuel, drier fuels, and things like that. So wildfires are part of what we call a reinforcing loop or a positive feedback cycle, or you might call this a vicious cycle, whereby we've got emissions driving a warmer climate, and a warmer climate driving more fires, which leads to even more emissions. And there are many things like this in our Earth system, in our climate system, that help to reinforce climate change, unfortunately. And as I say, wildfires are a really important part of this reinforcing positive feedback loop. So that brings me on to my second question. So hopefully I've dealt with how fires drive climate change. But what I wanted to also talk to you about, and this is probably what you're more interested in, is how wildfire is going to respond to climate change. Now, we've already talked a little bit about this because I've said the warmer climate is going to lead to more ignitions and more ignitability of fuel. But it is a really difficult question to answer. And I think this map kind of emphasizes this. I took this last night off the Copernicus EU website, where you can look at forest fire risk across the whole of Europe. It's free. Any of you can do that. And what we can see is where we are right now is in, let me just read the small, very high fire danger right now, standing. Now, I would argue that we're even higher risk than that, because we have maybe 10,000 people possibly 10,000 people that might want to light fires, barbecues, campfires. And so I would say the risk is actually heightened because of all of you lot being here at this festival. Secondly, if you look out the window of your car when you exit the festival, you're going to see fields and fields of parched wheat that have not been harvested yet, which to me is like a tinderbox. It's ready to go. It's very dry. There's a huge amount of fuel. So what I'm trying to say here is it's complicated. You've got the weather for a fire, but you've also got human factors, sociological factors, the fact we've got a whole bunch of people having recreational activity on this site, and you've also got farmers who have chosen not to harvest their fields yet. So you've got decision making, which adds extra kind of risk when it comes to fire risk. And so we need to consider fire like an organism. And in fire science, we call this fire ecology. Hopefully you're familiar with the term ecology, but ecology describes, why you find a particular species in a particular location. And for organisms, you need to have resources, you need to have food for that particular organism, you need to have conducive weather for that organism, it can't be too hot or too cold. You need to have some way for that organism to spread, to kind of disperse. It's the same with fires. Not only do you need weather, weather is important when and therefore climate is important, but you also need fuel. You need to have vegetation. You can't have a fire in the middle of a desert because there's nothing to burn. And finally, you need to have ignitions. And 90% of ignitions of fires on our planet are caused by humans these days. Very few caused by lightning, 90% caused by humans. So that adds a really difficult dimension to how we predict where wildfires are going to occur in the future when it comes to climate change, because you have to factor in the ignitions and also the fuel on the ground. Now, let's think about the fuel on the ground. There are two maps here. The bottom map shows us basically where all the stuff is on the planet that can burn. The darker the color, the more stuff there is that can burn. And on the top, you've got where the fires happen. And what you'll see here is there isn't a perfect correlation. If you look at the center of Africa in the DRC, if you look at the heart of the Amazon in South America, there's loads of stuff to burn. These huge amounts of carbon stored in the trees. But why doesn't it burn? Because we don't have the fire-conducive weather. It's too wet. If we look at the deserts, it's incredibly hot and dry, but we have no fires there because there's nothing to burn. So you need to consider, as well as the weather, you need to consider the fuel and the ignitions as well. Now, it gets even more complicated because climate change is not going to just affect the weather. It's not when it comes to fires, it's going to affect the fuel. We might see more growth in some places. We might see a shift in species in other places, which might be a shift to more flammable species, such as pine trees, or to a shrubland environment. Or we might see a shift away from flammable vegetation into, for example, a desert in some places. So where we might see very high fire risk at the moment, in the future it might become a desert and therefore we won't see fires there. So this interaction between fuel and climate is really important. Obviously, the weather is changing, and it's not just temperature that we need to understand, it's the relative humidity, which is really important for driving wildfires, but also wind. Wind helps fires to spread, and without the wind, you're not going to have a big fire. And again, we need to try and understand how climate change is going to affect wind dynamics across the planet. And these things are really difficult. We don't really understand how even rainfall is going to change in 50, 80 years' time. We get temperature pretty well, but rainfall not so well, and therefore that makes predicting wildfires really difficult. Finally, ignitions. No one has any idea about how climate change is going to affect lightning and the distribution of lightning on our planet. So again, this makes things very difficult for predicting the future. But nevertheless, scientists try to do this anyway. And I think this is a really interesting map. It's old now. It's 13 years old. And it's predicting what wildfire risk might look like by now, by the 2020s. It's actually for the date range 2010 to 2039. So we're kind of pretty much sitting in the middle of that now. And what you'll see is big areas of Siberia with higher fire risk, a shift in fires further north. And you might notice a red kind of coloring over northwestern Europe as well, which is important. And of course, we're already seeing this. So many of you might have been familiar with fires that have been occurring in Siberia and Canada and Alaska over the past particularly 2017 to 2020. This is a fire here in Greenland. So we think of Greenland as being, this huge ice sheet, but just past the ice sheet, you've got this flammable kind of shrubby vegetation, and we're seeing increased fire activity now in these very high latitude locations, which is a sign that we're seeing a shift in the climate and therefore a shift in the fire activity at these high latitudes. And finally, I think this is really poignant because this is the same paper, the same kind of researchers, and they've got a map for 2070 to 2099, in the very end of this century, when some of us won't be here anymore, and this is our children, this is our grandchildren's decade. And I'm just highlighting the UK and Northwestern Europe because what you see here is a very dark shade of red, which suggests that wildfires are going to become far more likely, far more intense. The activity is going to become more dangerous by the end of this century. But, and there's a big but here, because almost all of the people that I work with, we're on a WhatsApp group, we chat constantly. Just 2 weeks ago, we were training to be firefighters so that we can react as well as just do our science to some of these events. We were chatting, and of course on Tuesday we saw these crazy temperatures, and we saw people's houses burning down in Greater London as a result of wildfires. And I just want to emphasize how unusual this is. This has never happened before in the UK. We have never seen wildfires move from the wildland, from the agricultural areas, from the heather moorlands, and enter into urban areas and then set buildings alight. The weather was so extreme, the temperatures were so hot, the relative humidity was so low that the tiniest of sparks, the tiniest of embers from someone having a barbecue was able to light fires inside people's homes. And that was really unusual. And I'd have to say, many of us did not think this was coming as soon as it has come. We worked together on a climate change risk assessment for the UK government on wildfires last year. We're predicting this by the 2030s, 2040s, maybe. But to see it happening just last Tuesday was really shocking to the whole wildfire community in the UK. And therefore, what we're seeing here, the high temperatures, the extremes, the record temperatures, are a result of climate change. It's a result of the shifting distribution in temperatures and more likely to see these extreme highs. With that, we saw the low relative humidity, and it's no surprise that we should have seen this extreme fire behavior that was unmanageable from the fire and rescue service perspective. They couldn't fight these fires. It was too intense. We don't have the equipment to fight these fires yet. And so it kind of really brought it home to us that climate change is already here. And we thought we had a window of opportunity to adapt in the UK, but it looks like that window has already passed, and we need to really change what we're doing to mitigate this risk and adapt to our future. So to finish on a rather somber note, that was wildfires and climate change. Thank you.
Thomas, thank you so much. Kind of sobering but really important conversation. I think you and I were both watching. I work in news. You, obviously, it's your work watching those fires on Tuesday, and it really was quite scary in real time as they spread and as the flames consume the homes. Let's take our first question at the front here.
Why did, on the estimated thing, why did wildfires in Australia decrease?
Yeah, that's a good question. You'll have seen many places with decreasing risk. And that's not because the climate is getting cooler or wetter. Unfortunately, there are predictions built into this mapping exercise that the researchers did that takes into account not just the weather, but also the fuel and the vegetation on the ground. And I suspect in places where we see the lower fire risk, is something to do with the fact that there will no longer be vegetation there to burn in future. So it's related to desertification. And we know that places in Australia, places on the edges of the savannas in Africa, and places in South America as well are likely to become more like a desert in future than a shrubland or a savanna environment. And with that, even though it gets hotter and drier, you just don't have stuff to burn. So the wildfire risk goes down. And that kind of explains these areas where you see the lower fire risk in future. It was the same on the Tibetan Plateau as well. You might have seen that being a decreasing risk. Again, they're predicting a shift away from shrubs to more like a desert ecosystem.
Nothing left to burn. Another question at the back.
Hello there. You touched on it at the very end, but what can we do to adapt in this country, given that this sort of weather's probably going to become maybe even normal within the next 10 years?
Yeah, it's a great question. As you can imagine, I've been fielding questions like that from journalists since Tuesday, hence the bags under the eyes, by the way. It's been a very tiring week. But adaptation is the key word, because mitigation is a bit too late for that now. Climate change is baked in for the next few decades, so we know we're going to have a changing climate before hopefully it plateaus and maybe cools down towards the end of the century, if we do something about greenhouse gases. But adaptation is key, and we're already working on it. So I've worked with firefighters in the UK who have traveled to Catalonia to learn about how they fight their fires in what we call the wildland-urban interface, which is exactly what we saw on Tuesday. Learning about the PPE that you need to be wearing, the techniques that you use to put out a fire. Not just direct attack, where you use beaters and things like this, but indirect attack, where sometimes you have to set a fire to stop a fire from spreading. So that's from the kind of firefighting perspective. What we also need is what we call fire-wise communities. So when we saw the images of Weddington in East London, I think a lot of us were shocked by the fact that these houses were surrounded by huge shrubs, taller than their fences. And in places like Australia and California, the people who are living in those houses would have had to have cleared that land, or at least the people who owned the land would have had to have cleared that vegetation to lower the fire risk. And so we need people to be a little bit more aware of the fuels around them, and to consider their back gardens and the land behind their back gardens for fire risk, and think about, could that set fire? Is there a line where the fire could spread into my home? That was the problem when fire spread along the fences, along people's kind of bushes. They had connectivity between the wildland and their house, and you need to break that connectivity. So that's something else we need to work on. And then get not just the fire service involved, but whole communities need to be aware of the risk and what to do in a situation like Tuesday, where you've got the fire weather, the fire conducive weather. I personally think there should have been an all-out fire ban on Tuesday. People were having barbecues, which was absolutely crazy, because you may be responsible with your barbecue. You may put away the ash after the barbecue's finished insensibly, but when it's burning, you can't do anything about the embers that fly off. And if your neighbor has got a compost heap, and one of those embers lands in the compost heap, that's it. On a day like Tuesday, you've lost the compost heap and maybe lose the houses on that row of streets. So there should have been an all-out fire ban. So that's something else we need to consider when it comes to adapting to this changing climate.
Sounds like there's lots to learn. Another question over there.
Slightly following on, do you think there are areas of the world that are currently inhabited by people that will become uninhabitable very soon because of this effect?
Yeah, so there are two things here. I mean, there's just the rising temperatures for a start. So we know there are predictions that by the middle of this century, there will be places in China, in northern China, in India as well, where just let's not forget about, we can forget about wildfires for a second here. Just simply the temperatures and the humidity are going to be at a level where you won't be able to survive outdoors with just your human body response to that heat and humidity. You'd very quickly enter into kind of heat exhaustion and then death. So there are places where the human body will not be able to cool itself down effectively through sweating, for example, which is I'm doing quite a lot of right now.
Too much information.
So there's that. But then, yeah, of course, there are places where the wildfire risk, I think we're already seeing that in places in California. There are places in Mediterranean Europe now where the wildfire risk is just simply too high, that whole communities need to rethink about where they are. The problem here is that we've seen land abandonment in Europe. So many of these villages were once, like the villages surrounding us right now, were probably farming villages, and the land will have been grazed by sheep, and that keeps the fuel load down, so there's not much to burn when you have a fire. But what we've seen is the abandonment of those traditional practices. Sheep farming is no longer economically viable in much of Mediterranean Europe and in much of the UK as well. What's grown up in their place are these forests or shrublands. That increases the fire risk, but you've still got people living in the villages. It's just they're not farmers anymore. They're retirees. That's a problem because, sorry if there are probably a few of you in the room, but it tend to be slower and difficult to evacuate. And also tend to be a little bit stubborn when it comes to fire warnings as well. So you've got this perfect kind of storm of problems related to the demographics of these places and the fire risk, which the fire risk is going up. The demographics are shifting in a direction you probably don't want in an area of high fire risk. And that means we do need to rethink about where people live when it comes to this. Probably not yet in the UK, but I would have said that about the types of fires we saw on Tuesday 2 weeks ago. But certainly in parts of California and the Mediterranean as well.
Our next question.
Hi there. You just hi.
Hi.
You just gave us advice about how we can sort of consider putting in fire breaks. Personally, you also advised the government on fire risk into the future. Are there currently directives for the whole of the UK, for farmers, or for agricultural, for industry, that we have to have fire breaks, or is that not something that's yet being considered?
Yeah, so there's a problem with the UK government when it comes to wildfire, and that's that there are about 6 different departments which have some kind of remit over things that might be affected by wildfires. So there's no joined up thinking. And of course, the government is a complete mess at the moment. And to expect 6 departments to work together and actually come up with some kind of cohesive plan is just not going to happen. So it is difficult. But we do advise on some things, and some things are coming into place. So the Forestry Commission, on their land now, they have active wildfire management plans. The strategy for their plantations is no longer blocks of pine trees, which, if you look at anything planted in the 1970s, it's just like monoculture pine, which is incredibly susceptible to fire. But back in the 70s, they weren't thinking about wildfire risk in the UK. So now they plant with pine surrounded by more kind of fire-resilient species like aspen, coniferous trees, either in circles or in blocks, like a checkerboard. And they also have fire breaks installed as well to stop fires from spreading from one block to the next. So that's happening. In places where fire risk is high, like Northumberland, the Peak District National Park, the moorlands outside of Manchester, we have these fire-wise communities now. So you've got the landowners, the land managers, the water companies who own a lot of the land in these upland areas. They're all coming together to talk about the risk and what they need to do to lower that risk as well. Sorry. There's nothing, the important thing, and to answer your question in a nutshell, is, there's nothing overarching yet. The closest thing we have to an overarching report is the one that we wrote on climate change risk assessment for wildfires, and that kind of covers the whole country. Yeah.
Excellent, thank you. Next question.
If wildfires keep going, will we ever perish?
Now, I think we have a nihilist. And it's not just you. Many of my students are nihilists these days as well. I teach climate change, and it's really difficult to deal with that kind of what we call climate anxiety. And to answer the question, no. I'm pretty sure we're not going to perish. There are plenty of places on the planet with low fire risk. Most of our cities, we're not going to see fires getting into the middle of central London. There have been rules in place in London since 1666. Many people don't know this. You can't have a thatched roof in London because of the Great Fire of London. And that was to mitigate the spread of fire through urban areas. The risky places are where the urban areas meet the countryside. So that's the only place that we really need to be worried about, and make sure that we put in lots of plans to help avoid any of those fires spreading from the countryside into the houses on the edge of the countryside. But most places are safe, and there are plenty of places in the world that are too wet to burn still, and there will continue to be towards the end of the century. But I don't think we have to be worried about us all dying just yet.
Phew. Next question.
Hello. I want to ask, has there been any significant research or modelling into how the risk of wildfires and increased wildfires are going to affect global food production?
You've hit me with a difficult question there. Now, I don't know is the quick answer. I haven't come across anything that's looked at this, but I suspect that wildfire, just like rising temperatures and changing humidity regimes, is just another agent that is going to make growing things more difficult. It's another risk to crops, and in many places like the southeast of England right now, that risk is very high. But I suspect the extreme temperatures, the heat stress for many of these species, and in some places the shifting distribution of rains, more extreme rainfall at different times of the year, I suspect that's much greater risk to crops and food stability into the future than wildfires. as a kind of agent for wiping out a particular crop. I think it's more the climate change and the temperature and rainfall that are probably of higher concern, I suspect.
Okay, so one more there.
Hello. Hi. So there have been a few talks over the weekend about bees and otters and beavers and rewilding in general. So I just wondered, how do they all work together? Like, are otters good or bad for wildfires? What about the bees? Like, what are they, friends or foes?
It's a really good question, and I get this one all the time. And I find it a really difficult question to answer, especially when I'm on live radio, when they say, but what about rewilding? And there's no simple answer to this, because rewilding is important. It's really important for biodiversity in the UK when it comes to the bees and the otters, and that, you know, it's really important that we maintain our biodiverse environment. But we have to accept that if you are going to abandon land for rewilding or wilding, depending on what you want to call it, if you're going to abandon the land and just let it go, then inevitably 5 years down the line, and for about 20 years after that, you're going to have a period where you've got an incredibly flammable landscape, because you've got immature trees. Immature trees mean you've got a connectivity between the ground and the top of the tree. You've got shrubs, and all of this burns really well. And so if you are going to rewild or wild, you need to have an active fire management plan to make sure people are excluded from that land, so that you're not going to have a source of ignition. And if you are going to have a compartment of land that it's got a break around it, it's not connected to say a managed land where that you might expect to see a fire, or a national park where you might have someone having a barbecue, you're just going to have really incredible risk for 25 years. And then once the trees become mature, if say the destination is an oak forest, like you might expect for parts of England, then the risk is low again. But you're going to have this period where it's super duper risky, and you know, a lot of rewilding people want to say, let's just leave it, but you can't just leave it, because you're probably going to lose it. You actually have to like encourage the kind of end goal to happen. You can't just let it go. Otherwise a fire is going to come along and wipe it out, and all your efforts are lost. So,
Thomas, we're almost out of time, but there's two questions I'm going to take at the front quickly. First one there.
How do you know that all the landscape and all the bushes and all the trees aren't going to get wiped out by fires and humans are going to die out? How do you know that's not going to happen?
Okay, how do we know that? Now, the Canadians are incredible. They have been doing fire research since the 1970s. And what they do is they take a species of tree or a species of bush, and they take 100 by 100 meters of it. So something like to the end of that swimming pool over there in size. And then they come along in a helicopter and they set fire to it with a kind of like a blowtorch on the bottom of their helicopter, and they watch what happens, and they measure how fast the fire spreads and how intense the fire is. And they do this for all sorts of species, and they've identified species that are really resilient, that don't burn. And so, you know, there are definitely some species that are really bad and going to burn really well, and you want to be far away from them when they burn. But there are others that we know are quite safe, really difficult to burn, even in the most extreme conditions. And so those are the kind of species that we need to surround ourselves by, our communities, and also our kind of at-risk agriculture and forestry. Thanks to people who've been burning wildfires on purpose, experimental scientific fires, to tell us what's safe. And you know, it's really incredible what the Canadians have done over the years.
Good advice there. Right, one last really quick one. We're a bit over.
Due to wildfires, have you found out a number of maybe degrees Celsius it goes up every year?
So, that is a really good question, and it was in the diagram that I showed you. I guess the question here is, how big is the wildfire effect compared to everything else that humans are doing? So, you know, what degree C is the wildfires responsible for? Now, it's quite a small number, because every year our climate's only warming by a little bit each year. But of the total human impact on climate change, wildfires from deforestation and those smouldering fires are about 10%. So that's larger than the United States, all of their emissions from burning fossil fuels, for example. So it's a really big number, and if we can do something about those deforestation fires, that's going to really help us achieve our climate goals according to the Paris Agreement from a few years ago. So it's a really good question. It's about 10% of the total human effect.
That was an amazing talk, Thomas. Thank you so much. I think we've all learnt loads. Thank you very much.